So welcome to what will be a very short video lecture. Don't worry, there's another one for you to watch as well. We're going to talk a little bit about algorithms and program development, and this is something that we'll be talking about throughout the entire rest of the course, but I just wanted to give a really quick preview here. So algorithms are just like instructions. They're like a recipe to make your favorite chocolate chip cookies. It's just a set of instructions that tells you step by step what to do. And algorithms kind of get, I wouldn't say a bad rap, but they are misused. So in movies and in the media, you often see algorithms being referred to as these mysterious things that just work somehow, but we don't know how, and that's not actually what an algorithm is, and I think it makes it seem a lot more complicated than it really is. So the difference between an algorithm and a program, and programs, remember, are kind of what we have been doing so far. An algorithm is a more theoretical portion of a program, or a more theoretical idea in general. So an algorithm is how we solve the problem. It's like a theory, it's an idea, it's a set of instructions. If we continue our recipe analogy, the algorithm is the recipe. It's how you do something or how you solve a problem. The program is actually baking the cookies. So we're taking our idea, our instructions, and we're actually implementing them. To break the metaphor, essentially, a program is when you take this theoretical algorithm idea and you turn it into Python code. So algorithms have a couple of properties. One is that they're really detailed. If you have an algorithm or even a recipe that doesn't tell you all of the details of how to make your favorite chocolate chip cookies, it's not a very good recipe. And similarly, an algorithm that doesn't tell you exactly what needs to be done is not a very good algorithm. Obviously, an algorithm needs to work. If it doesn't solve a problem, if it doesn't actually do what you want it to do, not a very useful algorithm at all. Third, it's going to be specific. You need to be able to know what ingredients you need and what will come out of the algorithm. So if you have no idea what you need to put into the algorithm to run or what the output of the algorithm is, that's not going to be very useful. And you also need to be a little bit specific about the steps in between. How do we take these ingredients and change them into the final output? Algorithms also should be general purpose. This means that you should not only have one particular use for an algorithm. An algorithm shouldn't only work for this one set of numbers. An algorithm should be able to take in multiple different inputs and spit out the output that you would like. So things an algorithm needs. First of all, just like our code, it needs to be readable. It needs to be readable by us, and it needs to be readable by others. And this is really interesting, and I'm just going to take a quick detour here because this is something that I care a lot about. But you hear about all these algorithms in the media, and oftentimes they sound just like a black box. They make it seem like, oh, well, there's this algorithm that does something, but we don't really know how, and I don't know, just trust it. And that is not something that should be done. Our lives are increasingly influenced by algorithms, from the algorithm on Instagram that shows you pictures not in chronological order anymore, but it has an algorithm to decide what you would want to see in that moment. And it's the same thing for when Amazon suggests new items, or Siri gives you suggestions, or Google gives you results. All of these are a result of an algorithm. And as we get better and better computers and better at math, we are going to have more and more algorithms. And I think it's very important. This readability concept is very important, because we don't want to be in a situation where one day algorithms are deciding everything and we don't know how they're deciding it. A really good example is if you had an algorithm that helps determine who will get into a certain college, and actually we're not that far from that. We do have similar things implemented in schools. you don't want to have a situation where we don't know what the algorithm is using to decide who gets into the college. It might be using something that we really don't want it to use, something like race or gender. So this was an incredibly far stretch of a tangent, but I just want to point it out that like when you have a set of instructions for doing things, you want to make sure that people understand how you're doing them. So the things that make our very simple algorithms readable are good names for your variable. I know it's really hard, and I tend to sometimes name variables just like X or A, but when you're writing code that someone else is going to see or that you're going to see in a couple of months, it's really useful to use descriptive variable names. The second thing that you need is comments. Comments are, as always, very important to readability so that we know what the code is doing. And also good indentation. So the second thing that an algorithm needs is it needs to be robust. And we'll talk a lot about this once we kind of get to that level in our coding skill. But people are very unpredictable. You never know what they're going to do. I had a friend who put out a survey and they asked a question and they said, okay, how many people did you teach to program? And she made the mistake of leaving that box as just like a free response box. And you would think that people would put some kind of number there. But actually what ended up happening is she got some numbers, but she got people who put random symbols or people who put the word none or people who just typed out the letters. So you need to make sure that your program can handle when people do things that you may not expect them to do. And we'll talk a little bit about how this works later, but just one good example is you may expect people to type in all lowercase, and they might for some reason have caps lock on and type in all uppercase, and you need to be able to some degree, expect those kinds of things. So another thing that an algorithm needs is correctness. We already talked about this, so I won't drag on about it, but if your algorithm doesn't do what you want it to do, not a good algorithm. So the way that we make an algorithm is first we have to have a problem that the algorithm is going to solve, and we need to understand and visualize the problem. If you don't really understand what the problem you're trying to solve is, you're probably not going to come up with a really great solution. So you may want to ask yourself the questions, what even is the problem? Or what's an example of this problem occurring? So you want to think before you program, and it can be your gut reaction to when you have a problem or you need to write an algorithm to just jump in and start writing some code. And while that is fine, you usually want to have kind of a game plan of how things are going to work. And the way you get that is by first thinking about your problem in English before you put it in Python. So once you've gotten some ideas about how to theoretically solve your problem, you're going to need to write some code. And the first round of code that you write might be a little messy, and that's okay. That happens, and it's totally normal, and sometimes it's even better to just get some code down and make sure it works before you worry about it being really beautiful. But once you have some code down that works, you want to make sure you, one, test it, so try it out and then try it out again and try it out again, and also see if there's anything in your program that you can simplify. And then the last thing is once you have something that's working hopefully pretty well, you want to evaluate your algorithm. Is it working? Is it doing what you think it's doing? And is it solving the problem that you're... So that's all I have for you today on algorithms. We'll do a lot more of this in class, but until the next video, I will see you soon.